In this video, we're going to look at the difference between sensible heat and latent heat. Okay, so put very simply, sensible heat is the heat you feel when you put your hand near a hot source. Like a fire shown in this example, if there was an electric heater sitting here and you put your hand next to it, you would feel the sensible heat. Sensible heat is completely independent of moisture in the air. That has more to do with latent heat, which we'll talk about in a moment here. So there's three methods that sensible heat can travel. One shown here is called radiation. Radiant heat is the heat you feel from electromagnetic waves that come from the sun or other light sources. If you go outside on a cold day and it's 40 degrees and you put your hand up and you feel the warmth of the sun, that's from the radiant heat energy that's traveling here from the sun. The next method is called conduction, and you can see how the heat conducts itself through this metal rod coming into this person's hand. So heat traveling through a solid from one spot to another is called conduction. And then we have convection, which is very similar to what you see in your air conditioning system. So in this case, the fire is heating the air, and the hot air is coming up and hitting your hand. It's important to note that convection is just another form of conduction. In this case, it's done through the air rather than through a solid piece of metal. In terms of HVAC, we have several sources of sensible heat in our space. Of course, the sun shown up there, this computer. People put off sensible heat and latent. We'll talk about that in a moment. Anything plugged into a wall, copier, printer. I almost said fax machine. That shows you my age. Luckily, we don't have to deal with those anymore. And over here, you can see an infrared image of my office, which has the computer and a light source plugged into the background here. Each of these items shown here, including the sun and the people, are all sources of sensible heat load in your space. Here's a quick infrared scan of a corridor. You can see a lot of light coming into this space. Let's look at the infrared here and see what that looks like in terms of sensible heat. And you can see tons of heat coming in through the window. You've got radiant heat there, and you've got conductive heat mostly. If there's any air gaps, you'll have some convection there as well. What about the roof of that same building? You can see you got a bunch of air conditioning units up here. You've got the sun beating down on the roof, which is introducing sensible heat to the building. Here's an infrared scan of that same roof, and you can see the condensing units obviously putting off a lot of sensible heat. And the main heat contributor to the building there is the sun. Obviously, you can see the deck's really hot compared to the white surface of the roof. Here's another infrared scan, just showing some typical office devices. Again, anything plugged in, there's a monitor there, a laptop. I think there's a little coffee warmer in this scene too, is going to provide sensible heat loading to your space. There's the coffee mug. And of course, people provide sensible heat as well. So we talked a little bit about convection, which is a common way heat is transferred out of a little unit heater. So there's a little fan in here, there's an electric heater. You can see we started about 71 degrees here, and I'll go ahead and fast forward this a little bit. And as the air heats up, provides more heat to the space, this is adding sensible heat to a cold or cooler space through convection. Here's a really good example of what radiant heat looks like. So you could see the temperature on the left there is the space temperature, which is about 77 degrees. But look at the surface temperature of this door. This dark red door is almost 90 degrees. That's because the sun's coming through the window. The radiant energy, the radiant heat from the sun, it's hitting this door and it's heating up the door to be much hotter than the space temperature. Okay, here's another example of radiant energy. You can see the outdoor air condition is about 72 degrees, dry bulb, but the surface temperature of this deck is over 110 degrees. That's because the radiant energy from the sun is heating up this deck. So here's a grocery store scan. You can see I got this scanner recently and I just had a lot of fun with it, but you can see on the left is just a picture, and then the infrared version is on the right. And you can see there's some sensible heat being put off by the lights above, some sensible heat from the floor, and then some sensible heat being removed from the space from the cooling of the freezer doors. Okay, another example, electronics store. You can imagine there's tons of sensible heat going off here. I think I have a little movement on this infrared. So again, all these things we're looking at are providing sensible heat to the space. Okay, so let's shift to latent heat. Latent heat has to do with the moisture content of the air. Technically, it's the amount of energy needed to cause a phase change. For our purpose in air conditioning, it's usually a liquid to a gas or a gas to liquid. So what kind of items or things or occurrences add latent heat to a space? Well, here's a couple of examples so you can see the rain clouds representing any outdoor air we're bringing in through infiltration or intentionally that might have a large moisture content in the air. Then you have any type of water, fountains, sinks, water features add latent heat to the space. Also, people are a huge source of latent heat to the space as well. And then there's a little coffee mug here, one of my favorite beverages to drink in the office, which adds latent heat to the space. All right, so speaking of coffee mugs, this is a great example showing the difference between sensible heat and latent heat. So what you're seeing here is a lot of sensible heat. The hot pad, the hot plate that it's sitting on is very hot, and then the cup itself is hot. It does have a lid on it. Let's see what happens when we take that lid off. Okay, so what you're looking at here, we get my pointing right. The bottom number on the humidity reader is the dew point, so it's 58-ish. Now watch what happens when we take the lid off. 60, 66, 70. So the dew point is going up because we're adding latent heat to the space. We're actually adding moisture to the space and some sensible heat as well. Okay, so latent heat. This is a makeup air unit in the summer in the Carolinas. So you can see a lot of latent heat being pulled out of the air from this system. In this image, this is actually a HR show from last year in Orlando. You can see the sources of sensible heat here would be the lights, the displays, any demos that are plugged in. There's a bunch of TVs in here. And then the latent heat source primarily would be from the people or any infiltration that would be coming into the building. In a typical presentation room like this one here, again, you have sensible heat coming from the lights, the projector, all the computers plugged in, and the latent heat source primarily would be from people and any water that's in the space, open water bottles, etc. Sensible and latent heat are expressed in BTUs per hour, commonly noted as BTU capital H, BTU/H, or BTU/HR, all common notations of BTUs per hour. What exactly is a BTU? BTU stands for British Thermal Unit, and it's the amount of heat needed to raise 1 pound of water 1 degree Fahrenheit. 1 pound of water is about a pint. It's also been said that one lit match represents 1 BTU. Come to think about it, I should have a slide for that. I'm gonna get a match and make a different slide for that. Okay, we can represent sensible and latent heat on the psychrometric chart. So anytime you're moving from horizontally from right to left or from left to right, you are adding or removing sensible heat. Anytime you're moving down the chart, you're removing latent heat. If you're moving up the chart, you're adding latent heat. And generally, when we're dehumidifying and cooling a space, we're moving diagonally, removing sensible and latent heat. We hope you found this video helpful. Please like, subscribe, follow, whatever you can do to help us out. We'd greatly appreciate it.